Hi, boys and girls. We're on our last lesson, chapter 11, and it's problem solving with geometric measurements. Your objective is you're going to take everything you've learned from chapter 10 and 11 and apply it to real-world problems. So at the end of this lesson, you should be able to use area, surface area, and volume to solve real-world problems. Now you're going to notice that I only have one example for you, not this. But I have one example problem, and the rest are try-its because you guys know how to do this. This is stuff that I've taught you and that you're familiar with. You're just putting it all into practice. So when do we use geometry in real life? When you're decorating, any sort of painting project is going to use area or surface area. If you're carpeting, you're going to use area. You need to know how big is the room. What's the base times height of the room, or the length times width to find the area of the room. If you're into crafts, using fabric for sewing would be area. If you're wrapping a present, how much goes around the outside? That's surface area. Okay? I love wrapping presents, so I was thinking about that, and I'd probably wrap my presents even better if I calculate the surface area. If you're landscaping, like planting grass, that finds the area. If you're laying out mulch, like filling up a flower pot, that would be volume. Remember, volume is how much can go inside. Surface area is what's on the outside of the shape. The building, or if you were building something, roofing or siding would be surface area. If you were filling like a driveway with concrete, it would be volume. Okay? So, I like to think of surface area and area, but mostly surface area. That's the outside of the shape. And if you're filling it, wow, I am just sloppy handwriting today. That says outside. And if you're filling the object, or the inside, would be the volume. Okay? Alright. So this is the one example problem you get, and the rest are try-its. So, and please, with these problems, work with a buddy, because a lot of it is just, do you understand what they're saying to you? So this problem here, it says, Shedd Aquarium in Chicago has one of the country's few full-scale animal hospitals linked to an aquarium. Now an aquarium, just to break down some of these words, an aquarium is where they have like a museum with fish and underwater creatures. Chicago is a place, so Shedd Aquarium is the name of the fish museum in this city. And it has an animal hospital inside or linked to the aquarium. So they have a place where they take care of the sick fish. One tank used to hold sick fish is a rectangular prism. Now it's going to give us some measurements, measuring 75 centimeters long, 60 centimeters wide, and 36 centimeters high along the outside. I'm going to pause here, looking at my pictures. Okay, 75 centimeters long, 60 centimeters wide, and 36 centimeters high. I understand what they're saying. Now I also noticed that there's another box inside. That's interesting. I wonder what that's going to be. The glass on the tank is 2 centimeters thick. So it sounds like the tank is pretty thick itself. Meaning if you were to like knock on it, that's a pretty thick tank. It's not cheap, thin glass, but it's 2 centimeters thick. How much water can the tank hold? Ooh, how much water can the tank hold? Are we talking doing something on the outside or doing something on the inside? Now water is going to be a volume. If we were to fill this up, the inside would be volume. So the next question, which measure, area, surface area, or volume should you use to solve the problem? We're going to use volume. Okay. Now remember, our formula for volume equals length times width times height. We're going to underline the question we need to answer. How much water can the tank hold, which is volume. We're going to circle the numbers to use. Length, width, and height. But I also need to consider this 2 centimeters, because what that means is that this 60 inches, or sorry, the 60 centimeters isn't really 60 centimeters, because there's 2 centimeters on both sides that I can't use. Okay, because it's not really a tank there. So I'm going to take 60 centimeters, or sorry, let's start with 75, because that's our length. Our length equals 75 centimeters, but right here, there's 2 centimeters. On the other side, there's a 2 centimeter gap. So I'm going to subtract 2 twice. So if I take 75 minus 2 minus 2, it would give me 71 centimeters. Now, the reason I'm subtracting 2 is for this gap here on both sides of the tank. Now I'm going to take my width equals 60 centimeters. Remember, there's a gap of 2 centimeters each. So I'm going to subtract 2, which should give me 56. Whoops. That wasn't right. Hold on. 56 centimeters. Now, once I take 56 centimeters, I look at 36 centimeters for my height. I'm going to subtract 2 for the difference on both sides. 36 subtract 2 would be 34. 34 subtract 2 would be 32 centimeters. Now, I take my length, width, and height and put them back into my formula here to find the volume. 71 times 56 times 32. Now, see this? I need to multiply these. And what I'm going to tell you right now is pause your video, open a new tab, and type calculator into Google and multiply that on a calculator, because that's silly math to do. So I'm just going to use my calculator for it. So I'm opening up my Chromebook, going to the calculator. Could I solve this on my own? Yeah. But I'd probably make a silly mistake. It's 3,976 times 32. I'm going to do that one on the calculator too. Gives me, hopefully you got the same answer, 127,232. 127,232 centimeters cubed. That's what I love about technology, is that now we can be sure that this is the correct answer. Okay? Make sure that you understand how I got these numbers, which are different than the numbers listed in the problem. But it is based on understanding what the problem is asking you. Okay, next problem. So here's a try it problem. I need you to draw this in your notebook. You have an aquarium tank. Now, aquarium, we just talked about, is where they keep fish. And it's in the shape of a rectangular prism again. It is 40 centimeters long, 26 centimeters wide, and 24 centimeters high. Let's go ahead and write those numbers in. Use red. 40 centimeters long. This back side would be 26 centimeters wide, and 24 centimeters high. Okay? Now you'll notice the top of the tank is open, so there's no glass on top. How much tinting is needed to cover the glass on the tank? Now, tinting is when they take the glass and they add something to it. It's like a paint almost that changes the shape or the color of it. So it's kind of like painting the glass, but it's different. Okay? It's making it darker. What are you going to do here? If you're not looking to fill inside of the tank, but you're looking for the outside of the tank. But also remember, you don't have to do the top base. Go ahead and try and solve this on your own, because you do know how to solve this. Just think through the problem by yourself. Alright, so I'm going to kind of break this problem down for myself. Now, I haven't solved this problem yet. This will be the first time I'm solving it, but I think I can do it. Actually, I know I can do it. First of all, I'm looking at this front side. The front of the glass and the back. Front and back. Oops. And I need base times height So the front of the glass, the base is 40, and the height is 24. 40 times 24. Now that's going to be the front and back. Now, I don't know if I said this, but you guys can use calculators today. Use your calculator on your Chromebook for these big numbers, okay? So if I have 40 times 24, but remember it's the front and the back, so I need it to be, I want to write this a different way. I'm going to write it a little different. I'm going to do the same problem. The front equals 40 times 24. The back is also 40 times 24. Okay? Because if I'm looking at the tank, I found the front, base times height, and it also gives me the back of the tank. Now I'm looking at my sides, which would be 26. So I have side 1 is 26 times 24. And side 2 would be the same. That would be this side over here. 26 times 24. Okay? And then I have the bottom. The bottom would be 40 and 26. Now remember, I'm not doing the top because there's no top on this tank. If I was, it would be 40 times 26, but I'm not. Now I'm going to pause the video real quick. I'm going to multiply these numbers and then fill them in for you. I'm going to use a calculator so I don't make silly mistakes. Shh, Abigail. Sorry, hold on. Alright, let's try this again. So, I went ahead and I multiplied with my calculator, and I got these numbers here. 960, 960, 624, 624, and 1040. Now, once I have all of my sides, I just add them together, which I also use my calculator for. And I got 4,208. And now we're talking centimeters. And remember, surface area is squared. Okay, so that's how much you would need to cover, that's how much tinting you would need to cover all of the glass on this tank. And just remember, the reason why we didn't do the top here is because there is no top of glass. And so we didn't do the top, but everything else was the same. I want you to really use calculators here, because if you don't know how to do this part, calculator is not going to help you. So I want to take out the stress of multiplying and adding, and I want to see if you know how to do this. Okay? Any questions, please pause and ask. Alright, here's another try it problem. You've seen this picture before in one of the previous videos. This is a picture from Paris, France. This is called the Louvre Museum. It's in Paris, France. It has a square pyramid made of glass in its central courtyard. So outside of the pyramid, or of the museum, you see this beautiful pyramid. The 4 triangular faces of the pyramid have bases of 35 meters and heights of 27.8 meters. What is the area of glass used for the 4 triangular faces of the pyramid? Okay, so think about what it's asking you. It's asking you to look for how much glass is here in these 4 sides to this pyramid. We only can see 2, but there are 4, so you have to imagine the other 2 on the back side. It gave you the base and the height of the pyramids of one pyramid. So could you find the area of one pyramid by yourself now? Could you multiply that by 4? Would you need to find the area of the bottom of this base, or just the lateral faces? Go ahead, pause this, try it on your own, use a calculator when you need to. Okay, so remember to find, I'm going to just draw this pyramid over here. Whoa, that was probably the ugliest pyramid I've ever drawn. Here we go, that's a little bit better. So there's 4 sides to this pyramid because it's a square on the bottom. We're looking for the glass of the triangles, so we don't have to find the bottom because there's no glass on the bottom, right? That's on the ground. So we're just looking for the area of 4 triangles. So I'm going to find the area of one triangle first. Now the area of a triangle is base times height divided by 2. My base is 35. My height is 27.8. And I'm going to divide it by 2. Here's where I pull out my calculator. 35 times 27.8 is 973. Oops. Divided by 2. Abigail, shh. Oh, sorry, boys and girls. I can't use a calculator, apparently. Looks like I got 486.5. 486.5. So that is the area of one triangle. But how many triangle faces are there? So that's only of this front. Well, we have a front, we have a back, and 2 sides. So the front equals 486.5. Now, remember the back is going to be the same. And the sides is going to be the same too. Because all of them have the same base and height. And the other side is also going to be the same. So now I just need to add those together. I'm going to use my calculator. I could add them together, multiplying by 4. It's the same thing. It gives me 1,946 meters. Now we're talking surface area, so squared. That was actually the lateral area because we didn't find the base. So what I want to just stress one more time is that you guys have done all of this. All of this chapter has been working up to being able to solve these real-world problems because geometry is one of the most common forms of math in the world today. Okay, I really want you to try by yourself because this is what we did yesterday. There's a wax candle in the shape of a cube. The side lengths are 2.5. Remember, it's a cube. Okay, what volume of wax is needed to make the candle? Go ahead and solve this on your own. Alright, sorry, I got a hair on my iPad. I went ahead and I set this problem up. To find the volume, I need my length, my width, and my height. My wax candle is a cube, so if the sides are 2.5, now I did 2.5 because I would rather work with 2.5 than 2.5, which is the same thing, right? I can go ahead and solve this now. So I have 2.5 times 2.5 times 2.5. I'm going to plug these into my calculator because remember I told you could use a calculator today. And yes, you can use a calculator on your practice and on your homework. It gives me 15.625. Now I should probably change 0.625 to, what's that called? A fraction. Okay, let's see. I don't know that off the top of my head. Give me just a second, see if I can figure it out. Okay, hold on. Okay, I was trying to be all smart, seeing obviously at 11 o'clock at night I'm not very smart. But I did figure it out just by solving it the old school fractions way, and it gives me 15 and 5/8. Both which are correct because they're the same answer, but this is cubed because we're talking volume. Okay, or 15 and 5/8 inches cubed. Alright, so that's the end of this chapter and this lesson. Geometry is important, boys and girls. It's really important in your life, and you're gonna run into it a lot. So make sure that you really understand how to solve these problems. Yes, you'll use a calculator in real life and in your jobs and your work and your future schooling. So I don't feel bad about letting you use a calculator here because that's what real life is about. And if there's anything in this world, I want you guys to be successful in life. I hope you've enjoyed this chapter. If you have any questions, please ask.